Bismillahirrahmanirrahim. Assalamualaikum and good afternoon to all listeners in Malaysia and good morning to our distinguished speaker and listeners in France maybe, as well as to those in other parts of the world. A warm welcome to the 7th Distinguished Lecture Series organized by the Faculty of Engineering, University Technology Malaysia. A little bit of introduction about this program. When COVID-19 was declared as a pandemic by WHO, we saw that almost the whole world came to a standstill. And as a result, many employees, working people were confined to their homes and residences. Even though such a situation was regarded as inconvenient and may also be counterproductive, UTM and in particular the Faculty of Engineering saw this as a great opportunity to get connected with people around the world, especially renowned scientists and professionals. And thus, by making contacts with these esteemed individuals, Distinguished Lecture Series was initiated. Its maiden talk was given on June the 3rd, which is about 2 weeks ago. And we will continue this event with an average 2 to 3 lectures per week. So as for today, our distinguished speaker is Professor Dr. Azeddine Beghdadi from Université Sorbonne Paris in France. And to begin with, I would like to invite the Dean of the Faculty of Engineering, Prof. Dr. Muhammad Rafiq, to further introduce the speaker. So let me pass the screen to Prof. Rafiq. Prof, over to you.
Thank you, Prof. Said Rahman. Assalamualaikum and hello, welcome everyone. Welcome to UTM Engineering Distinguished Lecture Series, our 7th lecture in the series. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology Malaysia. Today, it is my utmost pleasure to welcome Prof. Azeddine Beghdadi to our program. So, a bit about our presenter today. Dr. Azeddine Beghdadi is a full professor at Université Sorbonne Paris Nord since 2000. He is the founding member of the Laboratory of Information Processing and Transmission, L2T1 Laboratory, and was its director from 2010 to 2016. He was promoted to the Exceptional Class Professor in July 2016. He started his education at ENSEP Oran, Algeria, and Physics Institute at University Oran Essenia. He obtained a master's degree in optics and signal processing from University Orsay, Paris in June 1983, and a PhD in physics with specialization in optics and signal processing from Sorbonne University, Paris 6 in June 1986. Dr. Beghdadi worked at different places, including CNRS Solid Optics Laboratory, CNEM Paris, and LPMTM CNRS Laboratory, University Paris Nord, from 1987 to 1988. Dr. Beghdadi has been involved in several international and national projects as steering board member, work package leader, or principal investigator. He has also served as a member of several expert panels of research funding agencies in France and Australia. He published over 290 international refereed scientific papers. His research interests include image quality enhancement and assessment, image and video compression, bio-inspired models for image analysis and processing. Dr. Beghdadi is the founder and steering committee chair of the European Workshop on Visual Information Processing, EUVIP. Dr. Beghdadi is an associate editor of Signal Processing, Image Communication, Journal Elsevier, European Journal on Image and Video Processing by Springer Verlag, Journal of Electronic Imaging, SPIE Digital Library, and Mathematical Problems in Engineering, Journal Hindawi. He received several awards for excellence in graduate research supervision and several Best Paper Awards at IEEE conferences. Dr. Beghdadi served as conference chair and technical chair of more than 10 IEEE conferences. He is a member of EUROSIP and IEEE MMTC and a senior member of IEEE. So that is a brief biography of our speaker. Here now is Prof. Azeddine Beghdadi from University Sorbonne Paris Nord to talk about visual information processing, models, applications, and challenges. Prof. Azeddine Beghdadi, over to you.
Thank you. Assalamu alaikum. Good morning, good afternoon. I would like first to thank Professor Mohammed Rafiq and Professor Hamad Zuri for this invitation. And I would like to thank also all the members of the organizing committee of this nice series of lecture. So my talk today is on visual information, and I would like to present these new some models, applications, and challenges. Okay, and I would like to present this theory. I mean, visual information processing through some applications. We are doing research to solve real problem, and the one of the most priority in research. The next, please. Next. So the motivation. No, just before motivation and context. So I would like to talk about the use of perceptual approaches for healthcare and security, which are one of the most the top priorities in applied research. So what's about the healthcare, because we know that there are many medical errors. We know that the third leading cause of death in US, for example, is the medical error. And there's also a problem with misdiagnosis, and we are around 2 million each year in the US. About the security, there are some statistics. For example, in France, for example, we have around 610 aggression and burglaries per day. And there's another issue with the security, how to protect the data from buying counterfeit or illegal copies. So now we are all facing this crisis, and one of the most important things to do in medical diagnosis is to process, for example, the CT scan, and to try to enhance or to improve the quality of the CT images in order to detect accurately or to analyze the severity of the impact of the COVID-19. So it may help to optimize the treatment strategy, to reduce the mortality and relieve the medical pressure. Okay, next. Another application which is very recent is in the frame of European project about the use of image processing and video processing for surgery, which is video-guided surgery. This is a workflow of this project. This project will be finished, will end in few months, and I would like to just to show you a video just explaining the objectives of this project, where the perceptual approaches are of great importance to solve some problems. So the video, what you're going to see, just so we are taking part in this project with our group and with other partners from different countries. I will let you listen to the video. Since that we don't have sound. The sound is missing. It's about the liver resection to remove the tumor, and the use of image and video processing. And so in this application, the quality of the images and the processing are of great importance. And the idea here is to guide the surgeon during the ablation of the tumor with the use of some processing. These are the partners. Thank you. Can we go? Next. Okay. There's another priority in research, which is about public security issue. And just to give you an idea about the statistics on the video surveillance, about the market, the market of video surveillance is really fast growing. And the number of the data recorded or transmitted through video surveillance system is very huge, about petabyte, which means that 1 petabyte is 1024 terabytes. Okay, let's go for the next, please. Now, in my talk, I will focus mainly on the perceptual aspect of the images and especially the image quality. And we know that in the video surveillance, the image quality play a prominent role. Can we go next, please? So now what we are trying to do, what people try to do, is to develop artificial intelligence-based video-based public security systems by using some learning approaches. This is the trend now, and this is the new approach how to improve the video surveillance system. Next, please. So this is a video, but unfortunately it doesn't work. It's a learning-based approach for visual tracking, just to how to learn the scene, to analyze, to understand, and to perform some visual tracking. So now, after introducing these two top priority research, I'd like to introduce what we call HVS, meaning Human Visual System Inspired Approach for image and video processing, scene analysis understanding, public security like video surveillance, and multimedia security. But there are other domains where the HVS inspired approaches could be applied efficiently. Next, please. So why perceptual approach? Because if you take any system of transmission of images, video, you know, we have during the capture, the acquisition of the signal, we have the human. The human plays a role. It could be a camera or a human. We have a human visual system, processing, analysis, transmission. At the end, we have also the observer to judge the quality and to analyze, to understand these images. It could be a doctor or any player or any other observer. So visual information processing is the way we treat this information by using some perceptual approaches based on the knowledge on the human visual system mechanism. You know, it is estimated that more than 70% of the information received by human is visual. But now, so let's go for this next, please. So let's start then by some basic notions on the human visual system. I am not going to go through all the anatomy of the human visual system, just to mention some notions that are useful to develop models for image and video processing. The first element of the human visual system is, of course, the eye, and the eye is, it works like a camera. You have optics and you have some cells, photoreceptor, and in the brain we have what we call the cortex, the visual cortex, and in this area all the processing and also the analysis of the visual information takes place. Next, please. This is a model of the human visual system. Of course, it is a sample because you know that the brain is the human visual system is one of the most complicated, complex systems in the body. It's a human body. And so we start from 3D scan. The optics is the eye. There is some sampling and in the retina where there are many million of cells. Then it goes to the cortex. In the cortex, there are two families of cells, which these cells are sensitive to the frequency, the spatial frequency. Another family category of cells are responsible of the orientation. Then we have transducer, and the last stage is more complicated. We have no clear model. We don't know how to model the detection and fusion stage in the human visual system. We use some mathematical model, simple, but this model could not reflect the reality. But we content ourselves with this. Okay, so what is needed if you want to develop an HVS-inspired model approach for image and video processing? The first factor that is important is the luminous adaptation, which is also related to the contrast. We have also the color aspects. In the eye, we have three kind of cells. And we have of different color, RGB. The CSF is the way the human visual system is sensitive to the frequency, the spatial frequency. We have the temporal, but also the spatial frequency. The masking, the visual masking is also important. The cortical mechanism that take place in the cortex, what we call the perceptual channels, we have to model this and to analyze the visual information. And we have also another aspect that is less studied and known by the community is what we call the temporal precedence or asynchronous analysis. I will explain you what. And the last is the fusion and decision. So I'll go through all these some basic notions, and explain briefly. So I removed many slides containing formula equations because I would like to make this talk suitable for a wide audience. Next, please. The first phenomena or the first aspect of human visual system is the image contrast. If you take these two square in a black background, they look similar. But if you change the background, you can see one of the two different from the other. This is what we call simultaneous contrast experience. Can you go next, please? So the contrast definition is there are many contrast definitions, and what is the best? The best, it depends on what you want to do. If you want to do just analyzing the images, or to enhance the contrast, filter the noise, to compress, to code, it depends. Some of the contrast definition or measure are suitable for some applications and other for others. So it's not, we don't have only a single contrast measure for all the applications. Next, please. One of the first work on the contrast, it started with Weber Fechner. The experiment is very simple, is to have a uniform background and you put a target with luminous L, O, like object, and we start the experiment with the background and the target with the same luminance. Then we increase the target by a certain increment, and when the target becomes just noticeable, we pick this value and we compute the ratio, the increment over the luminance of the background, and we plot in log plot. what can be drawn from this figure is that saying that in a large zone, the variation is linear, which is very interesting. And we have another zone that is, every zone is only for the sensitive noise and the saturation. But very often we work only on the Weber-Fechner zone. Next, please. So I told you that there are some, we have some sensitivity also to the spatial frequency, and the contrast depends also, the sensitivity contrast depends also on the frequency. If you change, here we have three grid, sinusoid grid pattern with different spatial frequency and the contrast. And we can see that the contrast varies with the spatial frequency also. Now the experiment, next please. So we can model this contrast sensitivity function. It looks like a bandpass filter, and the grid or the pattern shown on the right, it gives you an idea about the sensitivity to the contrast with respect to the spatial frequency. If you increase the frequency, in the mid frequency, the human visual system is more sensitive. It means that even with low contrast, you can see. The other aspect is the color. I am not going to talk about the color because there are many color space. Just let you know that the choice of these three color RGB is mainly related to the physiology of the human eye. And now with the technology, with the current, even very current standard display, you have 24 bits of information per pixel. It means that for the three channels, we have 8 bits. So it's 24 for the three. And the number of course, the number of color is it's huge, very huge, but not necessarily distinguishable. We could not distinguish all this color, of course. Next, please. This is the CSF plotted in the case of color, what we call chromatic, because the previous one is only for the gray level, luminous, and in this one we take into account the color. So we change the color of the contrast and we measure this curve corresponds to some model that fit the experimental data. Next, please. The other phenomenon is the masking, the contrast masking, visual masking. We have the signal and you have the masker. If you add the two, and the resultant signal, you could not distinguish the signal from the masker. But when the orientation is different, it facilitates the discriminability between the two. And the third example is very complicated because you have both the contrast, the spatial frequency is not so different, so we could not distinguish the two signal in the resultant signal by adding. This is an additive model, but we know that in the real scenario, it may be not only additive, this masking. There are some models that some of them are used, for example, for compression, for image quality assessment, and so on. Next, please. The texture masking. The texture masking, it means that on the left, we can see a dog. Of course, the dog is not very really distinguishable, but if I show you only the first image without a color, I think some of you could not distinguish this dog on the background. But if I change the color, it means that the color and texture, there's some interaction between these two. And it is there are some models that try to explain the interaction between these two phenomena, but it's not really very easy to derive a single model to explain this phenomenon. Next, please. Now the information arrives at the cortex, the visual cortex, and there, as I told you, there are two families, two categories of cells, because you know that in our human visual system, there is some frequency selectivity and also directional selectivity of this cell. There's two. One of the cells are responsible of detecting the spatial frequency and the other for the direction. So I just show you some example of the images that could mimic the functioning of the cortex when transforming, when analyzing, decomposing the visual signal. Next, please. Just this is a sample model. How to we have some model for this cortical transform in the human brain. It's just like a sine wave. You multiply by Gaussian, so you obtain the Gabor filter. It's very easy, and by changing the frequency of the sine and by changing the aspect of the Gaussian, and you can generate a different Gabor filter with different frequency band frequency. Next, please. This phenomena is very interesting. It has been used and introduced in image analysis by Berger and Poon a long time ago. It says that when you look at the image, the first object and first stimuli that are processed by the brain are the stimuli with high luminance. So when and through the time, during the time, it can accumulate. I mean, the other pattern comes into the brain, and at the end, what is saying that we don't process all the stimuli once, but in asynchronous mode. Next, please. It is justified by an experiment and a model proposed by Dogman, and which say that what we call the latency is the time when the luminance for stimuli with very low luminance, it takes time to process. The latency goes up. When the luminance increases, the time decreases. This law is really consistent with the asynchronous mode. Next, please. All these are not just a theory and model. It can be also justified by some experiments. Here it's a French team in Grenoble. What they do, they analyze the brain using functional MRI. They analyze the cortex activity when seeing images. So when they show an image very blurred with only low frequency components, the zone activated are really large. But when they show only the high frequency, only some components, some details on the image, only small area of the zone of the cortex is activated. So what we can draw from these results is that the low frequency and the mid frequency are more important. Next, please. This is justified by some experiments. We know that only low and mid frequency are sufficient to classify, to categorize the image. Next, please. Now, let me talk about the image quality and why image quality is so important. It is really important, especially in the medical context for diagnosis and also in video surveillance, but it is also important in other applications. But as in this talk, I'm focusing only on these two domains, I will introduce the image quality in this context. Next, please. For example, these results are very recent. How to analyze the chest X-ray just to confirm the prognosis of COVID-19. You know, if here we can see that the quality of the image is of great importance to take a decision. Next, please. In the context, if you see this image, you may think about nebula or any astronomical images, but it's nothing but the mammography. And you can see these bright spots. If you give this image to anyone, you say that, what do you think about this image? You may say that maybe these are the noise. I would like to remove this noise from this tissue. But this information is really the microcalcification. And what I'm saying that what may be considered as noise is really useful or important information. It is why the image quality in the medical context is very complicated, because when you search for the quality in the medical context, you don't search for the pleasantness, the aesthetic, or the high content. But what we want to do is to be able to detect and to interpret the lesion, and to interpret or to give a diagnostic for the image. Next, please. So if we, before, it's not really easy to collect data from in the medical context by asking doctor to perform some subjective test and provide their mean opinion score about the images. It's very tedious, it takes a long time. And what we did, we start from a database and we generate different distortions at different levels, so as to understand how the distortion affect the images, and to develop some quality metric, how to compute objectively the quality of the images, and how to process the images to remove this distortion. Next, please. These some samples from our database that is available on internet, and this just by adding what we did, we start from an original image, medical image, endoscopic images, and we add some noise at different levels, and we ask observer just to rank the image by using pair comparison, and we store all this data for different distortion at different levels. And the idea is to develop an intelligent system that is able to detect the type of distortions, and tells us the level also of, so as we can decide if we need to process or not this image. Next, please. There's another distortion that might happen in surgery. You have a specular reflection that is really annoying, but you can also have non-uniform illumination that makes the surgery very complicated. Next, please. So what we did, we tried to understand some of these annoying distortion, like the smoke during the video guided video surgery. We simulated. We have actual smoke and another smoke simulated by using parallel fusion model, and we can see that, of course, the distribution is quite different from the histogram, but the visual appearance is not. It's really similar, not very different, because we know that the gradable histogram of the three or the histogram of three components it may be the same, may be different, but what is important is the perceptual aspect, not the statistical distribution of the values of the pixel. Next, please. So I told you that remove many equations, but I can only just tell you that if you want to process images, okay, we need two models. If you model, you have an equation. For example, here we are using a physical model to remove smoke from these endoscopic video for surgery, video guided surgery. This is a model where you have the image, and it is really similar to the Hayes model. So I'm not going through all the details, just to let you know that if you want to process real applications, you need to derive model derived from physics or from the human visual system modeling. Next, please. Just to give you just the process, how we can remove these. We estimate using some variational approaches, and we remove the noise by this optimization method for minimizing this functional. We have. I'm not going to go through all the details. As I told you, I would like to have this talk suitable for a large audience. So let's go to the next. This is a video images, original images, and with after removing noise, smoke. Can you go to the next, please? Just some results. This is another example, enhancement of these. Just to what was the objectives is to help the surgeon during the surgery by providing video with good quality. Next, please. Another issue is about security. So it was in another project. So I selected only these two projects. The first was with the European community working on healthcare. The second in security, as I told you, these are among the top priorities in many governments when it comes to applied research. Okay, next, please. Just a brief story about the video surveillance. It started in the 60s in the UK, United Kingdom, and we have two important dates, is 1960 and 1998, where for the first time face recognition software that is automatic, completely automatic, has been developed in London Borough of Newham Begins. Okay, this is the first, to the best of my knowledge, it was the first face recognition software developed through the world. Next, please. So what are the challenges that we have to face with when it comes to video surveillance? We have the quality of action, of course, because I show you some statistics in the beginning, showing that the quality is of great importance when people want to choose a video surveillance system. The video quality, coding of transmission, because you are transmitting, and there's some issues with when coding and transmitting. The data storage, how can you detect abnormal event detection? How can you make the difference between really an abnormal and normal event in the crowd? How to manage time and research. And so now what are the trend is to use artificial intelligence systems. Is one of the most promising approach to solve all these problems. Next, please. So this is what now we are moving to the smart video surveillance system. This is just to show you some distortion that may affect the quality of the video surveillance. You may have noise, blur, smoke, as in the last image. All these are videos. In video, it's better to see this distortion, especially in the smoke, it moves. Next, please. The other challenge is how to detect face and to identify. Some people are saying that face detection, face recognition is solved problem. I don't think so. If you can see in some, even with using deep learning, as people are claiming, if you give the image on the top, on the right, and the bottom, you can't see anything. You have to increase the quality of this image before doing any face detection. And I will show you some experiment showing that the pre-processing is very important. Next, please. The video quality in the video surveillance system is very important. It's critical because now you start from video streaming, you code you send through the channel, the decoder, you see. So the idea, what is the problem? How to measure the distortion? This distortion is mainly due to the lossy coding, but also the packet loss through the channel. And the question is how to maintain the image quality of the video for a given bit rate. There's some trade-off to find. There is some solution for certain models, but we know that all the images or the video may not, follow these theoretical models. And very often we use some pragmatic or ad hoc method to solve this problem. Next, please. This is just to give you an idea about a smart video surveillance system block diagram, very complicated, many blocks, but I removed also some of blocks. What is important here in our work and what we are doing is to work on the video quality assessment block, because what is the idea? The idea is that when you acquire the image, we want to know, or the video, we want to know if the image is of enough quality or not. So what we do, we try to detect in an automatic fashion the type of the distortion. Is it noise, blur, uneven illumination, smoke, haze, etc. And we should also be able to say if the level of distortion is really annoying and it may affect the subsequent tasks. So it's really, this is what we are saying smart, because we are trying to understand before taking decision. The second part, which is really very important, is how to detect the abnormal event detection. So next, please. This is a typical example. You have a video on the top, and if you don't process this video, it will not be possible to detect the faces and to recognize the some people in the crowd. So the first step is the video acquisition. Of course, you measure the quality and you say, is it of good quality or not? Yes, we go to the face detection and the subsequent task like visual tracking. If not, we go for the pre-processing, as we did for this image. You can see down in the image on the video on the bottom that we can distinguish the faces. Next, please. Next, please. Image quality enhancement perceptual approach. As I told you, all the what we are developing here is based on the exploitation of some knowledge about the human visual system. Next, please. This is two image. You can see on the left the original image and the processed. Here we use a perceptual approach to process this image, and the video on the bottom is for video surveillance. You have some kids playing in a dark room, and if you don't process this image, you could not distinguish who is playing, who is inside the room. After processing, you can clearly see these kids playing in this corridor. Next, please. Here is just to show you, to demonstrate why processing before face detection is very important. Here, this is also a video, and we can see on the left image, we try to detect the face. We have a face here, but when we play the video, the system, here we are using a sample model of Viola and Jones. It's a very famous algorithm for face detection. And on the video on the right, after processing, the face is detected on all the frames, whereas on the previous frame, which is dark, the face, the system could not detect the face. So what we did next, please. We start from a database, many faces. What we do, we run the program without processing, and we compute the recognition rate. We found 49%, very low. So just by using a simple contrast enhancement based on equalization, again here we have 64. And when using this Retinix or perceptual approach, we have 60. Of course, all these recognition rates are low. The idea here is not to show you how to detect, just to show you the importance of the pre-processing in increasing the recognition rate. Next, please. I told you in the beginning that I am also going to talk about how to protect the data and how perceptual approaches can help in developing efficient method for protecting visual data. First application is the watermarking. The watermarking is a very classical, very known problem. You have two clients, a vendor, and one of the clients, Alex, is trying to sell or to copy, to make an illegal copy. And now, how to protect the data of the film, movie, images, video from this counterfeit. The solution is the watermarking. The watermarking consists in putting a mark into the video that is imperceptible and that can resist to any attack. Next, please. So there are 4 requirements for a good watermarking. The first is imperceptibility, what we call also transparency. It means that if you put something on the video, it should not be visible or image. The robustness is against any attack. The capacity, if you put if you insert the mark, it should not increase the size of the image of the video. It should be very negligible. And the security should resist also into some attacks. So how to find, there is, what we try to solve here is, there is a trade-off to be found between imperceptible transparency and robustness. Why? Because if you want to put a watermark, you want the mark to be the watermark very strong and very robust against the attack, you have to put more energy in this watermark. But if you increase the energy of the watermark inside the image, it becomes visible. So there is a trade-off. So how to solve this? By using human visual system, because who is going to see this watermark is the human, is the observer. So it is logical to put the human visual system in the chain. Next, please. What we develop here, it is based on what we call GND. GND, just noticeable difference, and we use the Gaussian multi-resolution decomposition of the image using the Laplace and the Gaussian pyramid, the Burt-Adelson model, what it is called Burt-Adelson. It mimics in somehow the functioning of the cortex, in the sense that, as I told you, in the cortex there are some cells that are responsible of decomposing the visual information into different components with different spatial frequency and direction. So we have 3 basic or essential factors to be taken into account in this model is the contrast sensitivity, the luminance adaptation, and the contrast masking. Okay, next, please. So this just to show you how does it look, this just noticeable difference map of the image. So the idea is to insert this watermark or this signature in the suitable, appropriate band component of the signal to make it robust and invisible. This is the idea. And by using this perceptual model, we can do it. Next, please. This is just to give you some details about the construction of this pyramidal model for inserting the watermark. Next, please. Promised is it is video. So what we did here, we do some attack, like to evaluate the transparency, and we measure this by using some image quality metric. To when we insert the watermark, it should be invisible, and we can compute this by computing an image quality metric to compare the 2 images. Next, please. This is another attack, which is embossing, just doing some pre-processing on the image. We try to break or to remove the watermark, and even by using this very strong deformation on the degradation on the image, the watermark is still present. As you can see, the peak. What we plot here is the correlation between the signal and the watermark, and it's showing that the watermark is still present in the image. It's revealed by this peak in the middle. Next, please. So what could be done now in the light of the deep learning era and the new with sophisticated mathematical models, and for to develop effective decision making, not only in the healthcare domain but also in security. Next, please. So there is now the trends, and it's to revive the artificial intelligence for developing efficient method for medical imaging and diagnosis, public safety and security, multimedia security. Next, please. So, deep learning in visual information processing, is it a lure or real opportunity? Should we trust in artificial intelligence? This week, very nice paper. I can share with you the reference. Just send me an email and I can share you. I downloaded it on, yesterday. A really nice paper. The title is Should We Trust Artificial Intelligence? And the authors really listed the most important requirements and concerns with the use of deep learning. I'm considering, some people are considering deep learning as a tsunami. Are we going to resist to this tsunami? I think that no one is going to resist to this tsunami. Many people now are developing method with deep learning, and as researcher, if you don't put any certain dose of deep learning, you may not see your paper accepted. This is really a problem. Let's go for the next, and I will tell you my opinion about that. Next. So what are we trying to do? All people are trying to catch this, what I call the deep learning train. We want to catch this train and to follow the trend. Is it the best way to do research? This is really a big question. Should we follow in a blind fashion this new approach? I don't think so. Can you go to the next, please? So, what are the open problems and what we can learn from this talk? The first is, as I told you, deep learning alone would not be sufficient to fix all the problems. Even through the internet, through many application conferences, we are seeing many applications, very spectacular applications using deep learning. I think that by combining the deep learning approach, what we know about the human visual system, and especially to solve the problem that are related to computer vision or medical imaging or video security. If in every domain, when you have to manipulate video images and using deep learning, if you use deep learning alone, it may produce some result, but I think if we marry the two, it may be a good option. So one of the open problems for students or PhD researchers that want to develop some perceptual approach is to extend this to multimodal visual information and the processing, analysis, understanding. It means visual tracking, detecting abnormal event in video. So, but when using human visual system inspired approaches, we should not, by experience, if you try to mimic the HVS, it will not work for many reasons, because it's very complicated to mimic, because you have to take into account of the many properties of the human visual system, which is very complicated. And the only options is to simplify these human visual system, HVS stands for human visual system models, and combine with classical signal processing, SPs for signal processing methods, to solve problem. Because sometimes when you want to optimize, you could not put this sophisticated, complicated, and complex models of human vision into optimization problem. You have to simplify. Next, please. Thank you very much, and sorry for not being able to run the video. Maybe the next. Thank you. So it's up to you to ask a question and to clarify things.
Okay, thank you. Thank you very much, Prof. Beghdadi, for the interesting and informative talk. So now I would like to open this session to the audience for question and answer. So if you have any questions, you can post it, and I will then read these questions one at a time, of course, so that our distinguished professor could address these questions, accordingly. Okay, probably we can start first while waiting the questions to come in. Prof, we see that nowadays this AI, deep learning, has become very useful and powerful tools. I mean, towards your last slides, you mentioned about the deep learning tsunami and things like that. But we know that this deep learning AI is just a tool. It's like a black box,
Yes.
and see that many people with even slight knowledge, they are able to make use of this deep learning in training and, for example, in object recognition and so on and so forth. So it seems that in image processing, the element of research is somewhat now missing, because people just use deep learning and then to get the results, to get output, to get the solution. So it's like now the element of research is taken out. So
Yeah.
what is your comment in this particular issue?
Yes, I totally agree with your comment. You know, it's some people are saying no, it's not a black box. You have no to. But the problem is now we are convinced that the way people, the major people using deep learning is like black box. Now, some people are trying to introduce the notion of explainable deep learning. Explainable, it means that we try to explain every thing in the deep learning, which is really not an easy task for many reasons. Because, as you mentioned, I read many papers, reviewed many papers. What they do, they use some architecture. They change the loss function, for example, the number of layers, the interconnection, and then they plot the results and they say, okay, we are the best. But if you tell them, can you explain why are you the best? You obtained good results, okay? But explain to me why your architecture is better than the previous one. What exactly? What they can say? By adding this, it gives more information and this and by choosing this function, it is more related to this. They can explain only qualitatively, but they could not prove anything by using reasoning, a clear and strong reasoning. This is one of the weaknesses of the use of deep learning. But now I have some information about some teams and even some PhD proposals. They're putting the word explainable deep learning for etc. for some application. So what I mentioned at the end, maybe we can learn from people working on artificial intelligence, but the question, should we trust all the artificial intelligence? The paper I mentioned, maybe I can share with you because I downloaded it yesterday. It's open access journal. I think the review is a Cell. This journal has nothing to do with the artificial intelligence, but people using artificial intelligence for in medicine, in diagnosis, in many aspects. And this paper really discuss. It's a really critical study and of the use of deep learning.
Okay.
Thank you.
Okay, there's one question, Prof, from Sarina Binti Sulaiman.
Yeah.
So the question is, to improve the quality of the images, especially the medical images, which techniques are the best techniques to be used?
Yes, in the medical images, the only problem that may arise when it comes to medical images is the notion of quality in the medical context is very often different from the quality for multimedia use. You may have a nice image, very contrasted, it looks nice, but maybe because of the masking, visual masking effect that may exist in images, it may mask some subtle details that are of great importance to the doctor. You may increase the count. Now, what's the method? I could not tell you, choose this one is the best. I think that the best way to process any image, be it medical or not, is to decompose the image in different bands, so as you can control what you are doing the performing contrast enhancement or denoising or elimination correction or any distortion by working on the spatial domain with global or even local. It is not efficient. You have to decompose, to decorate all the components, so as you can do some adaptive process in the different bands. Maybe you have to put more, you have to tune the parameters according to the importance of the different spatial frequency, the different frequency bands.
Okay, all right, thank you. Okay, seems that I don't see any more questions. I guess, Prof, your talk is so precise and very clear. I think they all have understood your talk in your lecture. Okay, so this is, we have a 1 hour already, so I think we reserve for 1 hour. Yeah. So thank you again, Prof. Beghdadi, for sharing your knowledge with us in this distinguished lecture series. It was really wonderful to have you with us today, and we hope that we will meet again physically once the traveling restriction is lifted. Sure. Then you have to go for this kind of virtual meeting.
And with video.
Yeah, sure. And also thank you for all our listeners for your patience and your attention. So let me pass the screen back to Prof. Rafiq, the Dean of the Faculty of Engineering, for the closing remark.
Thank you, Prof. Said, and to our distinguished speaker, Prof. Azeddine Beghdadi. Thank you so very much. Our deepest gratitude to you for sharing your knowledge with us. And to all of you watching this program throughout the globe. We have viewers from Europe, from Middle East, from Southeast Asia, Africa, and so on. Don't forget to like our Facebook page, because we have many more interesting lectures waiting for you. Do share this video to all your friends and colleagues worldwide. Thank you for watching. I'll see all of you in our next episode of UTM Engineering Distinguished Lecture Series. Bye for now.
Thank you. Thank you. Bye. Thank you.